Okay, so welcome to the next latest and greatest textbook review video. I'm still reviewing Malik's C++ programming textbook here, and I'm getting quite a bit of feedback from students that they do appreciate me going through the textbook and kind of highlighting what's important and what's not. But when they reach some of these exercises at the end, they feel like, especially when they're new to programming or C++, how do I fit all of this together, right? How do I take the information from this textbook and plug it into an IDE and get this program working? And so I thought, well, okay, why don't we do that? Why don't we go through a few of these exercises and really focus in on where the rubber hits the road, right? How do we translate these problems into actual reality, into a working solution, and how do we use an IDE like Visual Studio 2022, which is what I'm going to use here? How do we utilize that in order to create a program and meet the requirements? All right. It seems like quite a few students are okay with the first few questions here at the end of Chapter 2, asking you to do very specific things, and they call out exactly what each line of code needs to do. Where you're running into problems, at least from what I can tell, is when we get into something that's a little more vague, that's not calling out each line of code and just kind of gives you a high level. Write a program that does blah. And so kind of the first problem that I see here at the end of chapter, I think this is 2. Yeah, at the end of chapter 2 here is something like question 9 here. Write a program that prompts the user to enter 5 scores and then prints the average test score, right? And they, get more complex as time goes on, but I want to make sure that we can do problems, for instance, like this, and then we can work our way into some of the more complex exercises at the end here. So what I want to do here is start with question 9, and we'll see how much time I have, and maybe we'll try another one of these, and maybe I'll produce several videos like this. But please, if you like this video, leave a comment. Let me know. Is it, you want to see me using Visual Studio and working to find a solution to these problems? Do you want to see me going over the textbook and explaining the concepts maybe in a little bit of a different way? I'm getting good feedback on that. Or maybe it's both. Maybe I need to do both. Okay, so I've already kind of gone through most of chapter 2 already. I want to try to dive in here, and let's use Visual Studio to accomplish what it is that these problems want us to do. And right now I want us to focus in on here this question 9 here, writing a program that's going to allow us to do this in C++. So the first question is, well, how do we do that, right? There's lots of IDEs out there. I'm partial to Visual Studio. I've used Visual Studio for many years. I think it's a good product, and the community edition is free, so that is always a good thing as well. So go ahead and install Visual Studio 2022 and launch it, and once you do, you should see something that looks like, please hold, where'd he go? Here. Looks like this, and I've already closed out a lot of the introduction windows, but you should see an IDE that looks like this. And what we want to do right now, I don't have a project created, so the very first thing you want to do is to create a new project. Let's make sure, and honestly, I'm using Visual Studio Community 2022. Older versions should be very similar to this, so don't freak out if you've got, let's say, 2019 or 2017. The procedure should still be very similar. Okay, we want to come up here and we want to say File, New Project. All right, and in particular, let's just create an empty project, C++ project from scratch, and go ahead and click on Next. If you don't see C++ here, I believe you might need to install the C++ plugin for Visual Studio, but definitely we want to make sure that you have this option here available. Empty project, start from scratch with C++. Well, even no. Let's start here. Empty project. Let's click on Next. Give it a nice name. I don't know. What is this? Chapter. Nice descriptive name. Q9. Oops. Question. Chapter 2. Question 9. You know, give it an appropriate location on your computer. For me, I'm just going to use the. Maybe I'll give it a Chapter 2 folder here. For sure, you want a new solution, and solution name is typically the same as the project name, so we're going to leave that, and leave that unchecked as well. Alright, so good name, good location, new solution, solution name should be the same as the project name, and I believe just leave that unchecked. Go ahead and click on Create. Alright, please hold. Alright, here we are. Here is our new Chapter 2 project in Visual Studio. Notice that we don't have any files here. So what we want to do is we need to add at least one C++ file, right, in order to get started here. So if you click on the source files folder here, right click on it and say Add New Item, and we are going to say CPP file, and usually the first CPP you create is main, okay, because it will contain a main program. Alright, give me just a sec. Click on Add, and yeah, we see we have main CPP here. We have the actual text editor open with main. You can see main CPP here. Alright, and we are ready to start typing our code. Alright, give me just a second. Alright, so now that we have that, let's go back and figure out, well, what is it that we're supposed to be doing here? I'm just going to copy the text here for the question and put it here at the top of the program, and I'm going to put what's called a comment. If you put a // in front of in front of the line, it's called a single line comment, and basically the C++ compiler is going to completely ignore this entire line. It's just we include comments to help the human, and if you ever need to go back and modify your program later on, change it, you're gonna want comments, because imagine the program's 2 years old and you have to go back and update it, right? Alright, so this is what we want to do here, right? Write a program that prompts the user to enter 5 test scores and then prints the average test score. How do we go about doing that? Well, let me say this. Every program and every computer fits what's called the Ipo paradigm. There is always the input part of the algorithm or computer. There is always the process part of the algorithm or computer, and there's always the output of that particular process or computer. And that's the whole reason we created these computers, right? It's the whole reason we created programming languages, is to take a specific set of input, do something with it, that's the process, and then basically generate the output of whatever it is that the process came up with. Alright, so if we look at this description here, maybe I'll put Q9. If we look at this description here, write a program that prompts the user to enter 5 test scores. Well, we definitely need 5 test scores, but there's a couple of other things that I forgot to mention. With C++, every program starts with main. So we definitely want to make sure that we include a main method. Okay? Any function or methods need to have a body defined. The way that we define a body is with what's called these curly brackets. Alright? So I'm going to say, look, main starts here, open curly bracket, and I'm going to complete main down here and put a closed curly bracket. Notice what Visual Studio did for me automatically is it indented the code, and that's important because anything that's indented I know is inside of the main method. And later on, when we have lots of functions and lots of methods, yeah, it's really nice to visually see which code is part of which method. So this indentation is important, and some languages like Python won't even compile if your indentation is incorrect. So definitely try to get used to this indentation, and they talked about proper indentation at the end of chapter 2. Okay. Alright, enough about that. We've got a main method that has some sort of input, process, output going on. The other thing that we need to do for most C++ programs, you're going to be requesting input from the user via keyboard, and you are going to be outputting data to the console or the screen. If you want to do that, you're going to be using a lot of cin and cout statements that's mentioned in chapter 2. In order to make that easy on us, okay, we need to include the namespace standard. Okay, use the namespace standard, or STD. Alright, make sure you include that at the top of your program, and you're going to make life, at least in C++ land, a lot easier when it comes to using the cin and the cout statements. Okay, so this is the basic shell of every C++ program out there. This is what we start with. We start with main, and typically when you're using cin and cout, you'll go ahead and include that namespace standard. Okay, alright, so we've got our shell. Now the question is, well, in order to accomplish this requirement here, what input do we need? Well, obviously we need 5 test scores, right? So we need to declare 5 variables underneath of the input section that can store test scores, right? And let's assume we want to be super precise, right? There's a couple of different data types we can use. One is a double, which includes the decimal point, which if you want to be really precise with, let's say, financing or scientific applications, you use either a double or a float that includes the decimal point. And that's what I'm going to use here. There's another data type called an int, or an integer, that is a whole number that does not include a decimal point in it. You could also do that if you wanted. There's also something called a string that includes alphanumeric data that we just kind of display to the screen. But the problem with a string is we can't do any math. Any data type that's a string, we can't do any math to it. So for sure we don't want the string, and I'm going to go ahead and say let's go with a double. Right, let's go with a double. Just so that we can be as precise as possible. Could we use an int? Yeah, we probably could, and maybe at the end of this, maybe that's what we do. Alright, the other thing I'd like to highlight is a lot of programmers like to use these shortcut keys. Anytime you find yourself typing in similar code, if you go to the beginning of that line, hold down the shift key and press down, you can highlight that whole line, and then you can say, you know what, Control C, Control V, and copy and paste it as many times as you like. Okay, now typically I will say this, in industry, when you find yourself copying and pasting code, that's usually a red flag, that you need to be refactoring the code and abstracting things so that you're not copying and pasting. But right now, we're in Chapter 2. We're learning about this for the first time. I'm not going to go there yet. So just know that you can always Control-C for copy and Control-V for paste. And I've created, right, 5 test score variables for us. Also note that when you create a variable, you cannot have a space anywhere in this name. Okay, so that's why you don't see me doing this. You see how already the compiler says, what in the heck is score? Okay, so make sure when you're creating variables, and they can also not start with numbers. So typically it's just safe to always start with a letter, and then you can stick a number on the end if you like. Alright, so these are our 5 different variables that we can use to store the 5 different test scores. And that is what the problem is asking us to do. Fair enough. Alright, what else do we need to do? Well, for input, I think that's basically it. That is all of the information, that's all the variables that we need to declare. But notice at the beginning here, it says write a program that prompts the user to enter these 5 scores. So for the input section, we do need the user to be able to type these in. Excuse me. Type these in, right? So first things first is, well, let's tell the user, hey, you need to type in some scores, right? So we're going to use our cout statement here. Okay. And in fact, what we might even say is enter 5 test scores separated by a space. I don't know, maybe you can hit enter after each one. Okay. Notice we have to put a semicolon at the end. Oh, and what happened to my cout? Right. So for a lot of these C++ commands that come in handy, we have to do what's called an include statement at the top. Alright, this will bring in, and notice I used the IDE to automatically generate that for you, but you can always just go to the top of the file and type this in also. Alright, we need the IOStream library in order to use the cin and cout statements. So as soon as I tried to use that cout statement, you know, the compiler was like, hey, no idea what you're talking about. As soon as I included the IOStream library, it said, ah, okay, I'm cool. I know what cout is now. All right, so don't be afraid of that. A lot of students who are new to programming are afraid to type in a line of code because they're trying to think of, well, what exactly do I need? What is the very first thing I need to type in? You can always come back and add things later, right? If you miss a variable, you can come back up here to the top, add another variable. Just kind of type in what you know at that point, and just as you're typing in that line of code, make sure there's no errors. If there's errors, well then fix them as you go. Okay, and that will become easier over time. So yeah, we need to tell the user, please enter these 5 scores. So that's going to print that out to the screen, but now we need a statement that's going to read in input, right? And we talked about that in Chapter 2. There is a statement called cin, or cinput. Now notice the redirection operator here is the different way. For cout, we go to the left with less than, less than. For cin, we go to the right, because we're basically saying take whatever's in input, which is the keyboard, and pipe it into these different variables, right? Like test score 1. And notice that we can input more than one variable at a time. Oops, wrong way. There we go. Test 3. Test score. Test 4. Yeah, notice how nice Visual Studio is. It even auto-completes. Oops, wrong way again. A lot of these things for us. Okay. So now this line of code here, so maybe we put some comments in here. Prompt the user to enter. Oh my gosh, I cannot type today. 5 scores, and then here we say obtain the 5 scores from the user, and that's what the CN statement does, right? And maybe just to be on the safe side, let's go ahead and see out to the screen an end L or an end line. That way, when we do another see out statement later on, excuse me, it's not hanging off the end of all these scores when we run the program. Okay. All right. So that should, in the input section, declare all the variables we need, grab all the scores we need. Now, what else does this program need to do? So we've done this part. Prompts the user enter 5 test scores, and not only does it prompt the user, it has them enter those 5 test scores, and then print the average test score. Uh-oh, we need the average. Prints the average. So the process part of this program, right, is going to be the average. So here, fair enough, let's create an average, and that's going to be equal to, right, test score 1 plus test score 2, and I'm going to change the 4. There we go. Alright, so we're going to add all 5 of those together, and we're going to divide by 5.0, right? Because we are obtaining the average. Notice that the compiler does not like me. Why? Well, it says average is undefined. What it basically means is you have not declared. Remember, before we can use a variable, we need to instantiate it or create it before we use it. And typically it's good programming practice to declare all your variables at the top of the function, not in the middle. I don't even know if C++ will allow you to do it. I know other languages will allow you to declare a variable in the middle of the program, but I don't believe C++ is one of them. So I'm going to go ahead and go up here and say, well, you know what? We also need an average. And maybe I even initialize it to 0. And that's another good programming practice. Most newer languages will automatically initialize things to 0 for you, but there are quite a few older languages that will not. So I'm just kind of used to always initializing my variables to 0. Alright, so we created average, and now it should be able, right, to go ahead and take all these test scores, add them together, and divide by 5. And then at that point, right, at that point, we should have our average, and let's tell the user, well, you know what? The average test score is, and let's give them the average. Oops, hey. Is average, and let's throw an end L on the end there so that it'll force the cursor onto the next line. And then yeah, so this is our input where we obtain all of the data that we need for the program. This is the whole purpose of the program, right? Taking all that input data, creating the average, and then the output is, well, let's report that average back to the user, right? Otherwise, only the computer knows what the average is, and it's kind of a pointless program for the human. And we're pretty much there, I think, other than you're going to learn what a return value is later on. Just know that because we have an int here, or an integer, we have to say return 0 at the end. We'll learn about return values later on. Okay, but the whole reason we need a return 0 here is because we have an int return value here. And again, if that doesn't make sense to you, it's not, we're not there yet in the book, so don't worry about that. So this to me looks like a good C++ program. I'm going to hit save, because you see how there was that little star up there? That means that I hadn't saved the program yet. And then I'm going to say, you know what, let's build it, let's compile it, and let's see if we have any errors. We do not. One succeeded. That's exciting. Alright, so now most people go, just run it and see what happens. I typically like to use the debugger first, because your first version of the program is always your best guess, but usually it's not right. And so what I like to do is set a breakpoint here, and if you click in this column over here, you'll see a little red dot. Alright, and when you see a little red dot here, that means that when you run this program, the computer's going to pause and wait for you here. And that's going to allow us to do a bunch of things. And when you work in industry, when you program in an industry, they do expect you to know how to use the debugger. And so I always like to teach my classes where we start using the debugger immediately. It's not kind of, well, wait until you need it. No. Let's use the debugger immediately, and let's see how much cool stuff it's going to tell us. Alright, so let's put the breakpoint there, and let's come up here and push this green button, run the local Windows debugger. Okay, and what we're going to see is, alright, it launches the program, which is what this black window is over here, and it stops right there on line 10. That's why this yellow arrow is here. This is what's called the program counter. So the program counter, okay, has stopped here, and it's waiting for me to tell it what to do. There's a bunch of different commands that we can do here, and they are located up here. And this is with all IDEs. This is with IntelliJ, Eclipse. Any industry standard IDE has a debugger. You can set a breakpoint, and then it has at least these 4 debug commands. Step over or next, step into, step over, and step out. I use all of these, but for right now what we want to do is use step over. You'll use step over the most. Okay, when you step into and out of functions, when we learn about functions later on, you're going to use these two a lot, step into and step out. But until we get to functions, you're basically going to always just use step over. So I'm going to click on step over here, and we should see it go from this line to this line, number 1, right? Because it's just going to advance to the next line. Number 2, notice down here there's an autos window, and this autos window will show us the variables that have been declared in memory and what their value is. Notice what test score 1's value is right now. It is rubbish. It is -9 bazillion. It is complete rubbish. So you're wondering why I initialize my variables to 0. This proves my point. When you create a variable, who knows what value the computer is going to put inside of it. So when I do a step over here, we should see test score 1 go to 0, right? Because of this, test score 1 equals 0. So I'm going to hit step over here. Boom, test score 1 went to 0. Here's test score 2. When I step over this, we should see this also go to 0. And so that's what you want to do, is you want to slowly, methodically do a step over on each line, look at the variables in the variable window, look at their values, and say, okay, does that make sense? Because if it doesn't make sense, you've got a bug. You've got a bug in your program. Just because it compiles doesn't mean you don't have bugs. And the only way you can find bugs is with the debugger and step through each line of code. So far, we haven't found any bugs. So far, every line of code, right, test score 4 equal to 0 because we just ran this line of code. Right now, test score 5, as soon as I hit step over, we should see it go to 0. And it does. And then finally we have average here. We should see average go excuse me, to 0. And we do. Alright, I was hoping that I got this little thing in the way. There is another window that will allow you, give me just a second. There is another window that will allow you, here we go, the locals window. This will allow you to see all variables currently in memory. Okay, and this comes in very handy. So I like to always have my locals window up. Call stack, we'll talk about that later on, once we get into functions calling functions. Alright, so far we've executed all lines of code in the input. We're here. We see all the variables that we expect. They're all 0, and this is all what we expect. So far we're good. Next, we're going to execute line 18. I'm going to hit step over, and we should see in the window, notice that it doesn't automatically pull up that black window, the console. So we bring it to the foreground, and absolutely. We just said C out or C output this to the screen, to the console, and that's what it did. Next, we're going to step over line 20, which says we'll C in or input these 5 test scores. So when I click step over here, you're going to see that it kind of hangs because it's waiting for the user to type something in here before it can continue executing. So let's type in 5 scores, 10, 20, 30, 40, 50. I'm going to hit enter. Alright, look what just happened. I typed in those 5 scores and it automatically knew that the first score goes in test score 1. The second score goes in test score 2. It took all of that user input and it put it right here into each one of these variables. So in memory, this is what these variables are equal to right now, and that all looks good to me. So far the program is working as intended. Okay. Now we're going to see out end line, and what we should see, because here's where the cursor is now. Oh, because I hit the enter key. It went to the next line. So I guess this is to be on the safe side. Let's go ahead and hit step over here, and what we'll probably see is, yeah, it went from here to here. So endl just pushes it down a line. And now here, here's the other cool thing about Visual Studio. If you hover over these variables, it will show you what the exact value is inside of each one of these variables at this instant in time. Okay? So it's going to take all of these values, 10 plus 20 plus 30 plus 30 plus 40 plus 50. I don't know, what is that? 100, 150. 150 divided by 5 is 30, right? So when I hit step over here and we look at average, it's equal to 0 right now, but we got to step over. Once we step over this, we should see average go to 30. Should see average go to 30. Aha! Average is 30. Average is 30 here. This is doing what I would expect it to do, so I say we're still good to go. No bugs detected yet. Now we're on line 27. Well, when I step over 27, right, that should print whatever's inside of average here to the console, along with average test score is in front of it. So let's see if that happens. I'll hit step over line 27, and we go to the console. There it is. Average test score is 30. Alright, so that seems to work out fine as well. And if we hit step over here, I believe the program terminates. Return 0, then terminate. Okay. If you run it, this is the other thing, a lot of new students who are new to programming, they run it. Oh my gosh. Is this run? Start without debugging. Right. Alright, so if we start without debugging, let me show you something. Oh, so the older versions of Visual Studio would immediately close this window. At least now, by default, it doesn't immediately close this window, so that's good. If, for whatever weird reason, you have a version of Visual Studio and when you run it, it automatically disappears, you'll see like a black console screen pop up and then disappear. It's running your program, it's just running it so quickly that you can't see it. You can, I believe, at least with the old versions, you could add this command here if you have a Windows machine. And I believe that will also serve the same purpose. Yeah. Okay. So if it's closing the screen real quick, just add a system pause. You could even add another CN statement down here. You just got to force the computer to wait for the user to do something, basically. Okay. So, wow, I didn't realize it would take this much time to get through one example, but again, I don't like powering through problems and going too fast because there's a lot going on here, right? Number one, we had to determine the code that would solve this problem. Number two, I wanted to make sure you know how to use the debugger in order to step over each line of code, see it down here in the variables window, and make sure that everything looks good. All right. We also learn how to create the project from scratch. So I think that's basically where I'm going to leave it today. If you like this video, if I'm on the right track here, you know, please leave a comment. Let me know. I'm going to try to do both, go over the textbook material and do these programming problems in Visual Studio so that you can see how it all fits together. But I do have a limited amount of time, and I'm trying to wonder if I should focus in more on the exercises or focus in more on the textbook material. Any input that you can give me there would be really good information. Okay, so have a great rest of your day, and I'll hope to create another webinar video here sometime soon. Thanks.